Okay, guys, what is a system of equations? Yeah, we did. We spent a lot of time on it, right? So tell me what it is. Several different equations. And what is significant about this system of equations? So when you solve it, where's the solution? Where they cross. Okay? Where they cross each other, not where they cross the x-axis. That's something different, right? A system of equation has a solution where they cross. Okay? So when we did systems of equations before, we did systems of linear equations, right? That means we had two lines. Okay? We had something like this, where one of our lines was right here, and one of our lines was right here, and that was the solution, because that's where they crossed, right? That was one possibility. Wasn't there another possibility? Here's one line. Here's one line. Where'd they cross? Never, right? So this had one real solution. What did this one have? No real solutions. And then there was another possibility like this, where here was the first line, and here was the second line. Yeah. Infinite. I spelled that wrong. I'm pretty confident. T-E. Sorry about that. Infinitely many solutions, right? Every point on the line was a solution. And that's all fine and good, because systems of linear equations are important. But they're not the only types of systems of equations. Today we need to talk about some nonlinear systems. Now, just because something is a nonlinear system doesn't mean any of the equations in the systems are not lines. Some of them could be lines, but by the system, by definition, is nonlinear if they aren't all linear. Does that make sense? What were the ways that we knew how to solve a system of equations? Matrix. Substitution. Elimination. One more. Graphing. Good. Those are the ways that we talked about solving systems of linear equations. Okay? We can do all of these except for one in nonlinear systems. And guess which one it is? Can't use a matrix. Okay? Can't use a matrix when we're solving nonlinear systems. So remember when I told you learning substitution and elimination was really important? And you guys were like, nah, I'll just use always a matrix. Well, now you can't. So I hope you remember substitution and elimination. We're going to talk about them today to remind you. Okay? So first of all, I want you to think about this for a second with me. Okay? Now that we're in quadratics, hopefully you realize we're going to maybe do two parabolas, maybe a parabola and a line, things like that. Okay? When we had two lines, these were the possibilities, weren't they? What if I have a line and a parabola? How many possible solutions can I have? Two. Okay, so that might look like parabola and a line, right? Here's one and here's one. Is that it? Can you have one? One solution? What would it look like? If I have a line and a parabola, am I allowed to have just one solution? How? Okay, so if the parabola is here and the line is, it doesn't actually just have to go through the vertex, but it just has to go through just one point on the parabola. Now in geometry, you know what that line was called, right? What was it called? Tangent, right? So a system of inequalities that's non-linear, so we have a quadratic and a line, that might be a tangent line, right? Now it could go through the vertex, that's entirely possible, but it might just go through one point on the side. Okay? Is it possible to have no solutions? Yes. What would that look like? It's not touching. So the parabola might be up here and the line's down here. Right? So that one has one and that one has none. Is it possible to have 3 solutions? Now, to be clear, I'm telling you right now that all we have is a line and a parabola. Can you have 3 solutions if you have a line and a parabola? Will the parabola ever come back down to cross the line? No. So can you have 3 solutions? No. Okay. What if we had 2 parabolas instead? What kind of numbers of solutions could we get? 2 for sure, right? Here's one parabola. Here's one parabola. So 1, 2, right? What else could I get? Could I get 1? How? If their vertices were touching, that's one way. Like right there. Okay. How else? If it was like this, except for parabola right there, right? Could you have no solutions?
If they're just like sideways, not touching.
Like that. So that's no solution. Could I have 3? Could you think of a way that I could have 3 solutions? I can. Yeah. But I kind of tricked you into lazy thinking by what I drew. Because the way you have 3 solutions is like this. You're allowed to have sideways parabolas? We studied them, didn't we? 1, 2, 3. Could we have 4? How? Further up, so like that. 1, 2, 3, 4. What about 5? So I would need another system, right? Another equation with my system. Then I could have 5, and then I could have 6, and then I could have 7, right? But if all I had was 2 parabolas, could I have 5? No. Okay? So it depends on the size of your system. Will depend on how many solutions that you get. Fair? Okay? Not going to really go into graphing too much because we've kind of talked about this. Not really going to give you any specific examples because you just graph the parabola and see where they cross. Graph the line, see where they cross. Graph the system and see where the system crosses, each equation crosses each other. But you know now that you can have more than one solution, can't you? Okay. What if you were given this system of equations? Y equals x plus 4 and y equals x plus 2 squared plus 1. And I said solve this by substitution. How would you go about solving this system of equations with substitution? If y equals this and y equals this, don't these equal each other? Aren't you substituting this into here? So x plus 4, we've put that right in there, right? The whole thing right in there, equals x plus 2 squared plus 1. Why do we have to study systems of nonlinear equations? Everything in your life that happens linear. No. Thank goodness. Okay. Now what? How do I solve this? What type of equation is it now? It's a quadratic, so I probably want it equal to 0, right? I know I want it equal to 0 because I've got an x here, an x squared here, and I'll end up with another x term here and an x here, so I can't just solve it with square roots, can I? Okay, so how am I going to go about solving this? I got to do something first before I subtract x and 4. I need to distribute this, don't I? Okay, so I have x plus 4. I have x plus 2 times x plus 2, x squared plus 2x plus 2x plus 4. So that's going to be x squared plus 4x plus 4 plus 1. So that's going to be what? 5. Okay? That's 5. Now can I subtract the x and the 4? Okay, if I subtract x here, and I subtract it here, and I subtract 4 here, and subtract 4 from that, right? So 0 equals x squared plus 3x plus 1. Now, how many ways do we know how to solve this? At least 5, right? Which way would you like to try first? Factoring. Okay, what multiplies to be 1 and adds to be 3? Nothing. So we can't factor it. Graphing at this point is kind of a moot point because we know it's not going to cross at any nice places because factoring didn't work. So we got completing the square and quadratic formula.
Complete the square.
Complete the square. Okay, so if I'm going to complete the square, what's the first step that I do? Good, -1 from both sides. Okay, so -1 equals x squared plus 3x, and then I have this space. What's going to go in that space? What do I do with this x term? Divide it by 2. And then what?
Square it.
Square it. I promise this will be easier if you leave it as a fraction. I know you don't believe me, but I need you to trust me. Okay? So what goes right here? 9 over 4. So if I add 9 over 4 right here, add 9 over 4 over here, right? In order to add fractions, what do I need? Common denominator. Isn't this really 4 over 4? Oh, that was magic, wasn't it? Okay? Not really, it wasn't magic. 9 minus 4? So 5 over 4 equals what? What do I do with this trinomial? Where do I go after the trinomial? To the binomial, right? What's the binomial that matches with this trinomial? X plus 3 over 2. Remember, it's either half of this middle term or the square root of that number, but those two things should be the same, shouldn't they? You with me so far? Now what? Square root both sides. Because now we're able to solve it with square roots, right? What's the square root of the left-hand side? Plus or minus, first of all. Plus or minus. Do you know the square root of 5? Do you know the square root of 4? Yeah, so let's leave it square root of 5 because I don't know that. Over 2. Now, I want you to make it very clear that I'm not taking the square root of 2 anymore. How did I make it very clear? I made that longer, right? Made it a little bit longer so that it was clear that the square root of 5 is the only thing that's being taken the square root of, right? Equals what? X plus 3 over 2. How do I solve for x? Minus 3 over 2. Now, look, these have common denominators already, don't they? So can't I combine the numerator and leave the denominator? So I have negative 3 plus or minus root of 5 over 2. You okay so far? Okay, I'm going to show you something real quick. I'm going to start right here with this equation. X equals negative b plus or minus the square root b squared minus 4ac 2a Well, that's 4, right? 9 minus 4 is 5. Huh. Doesn't matter which way I do it. No. I'm still going to get the same answer, aren't I? This is my answer. But we have to be careful, don't we? This solves either completing the square or the quadratic formula. Where is the solution to my system? Where is it? You told me a second ago. Where am I looking for my solutions? Did you forget already? Where's the solution to any system of equations?
Where they cross.
Where they cross. Where do solutions cross? Or where do systems cross? At a point, right? X equals blah, blah, blah. Is that a point? No. That's not a point, is it? This doesn't mean anything for me yet. What I just found was the... How many answers do I have right here, by the way?
2.
I have 2, right? What I just found is the x coordinates of my solution. And this doesn't mean anything to me. So in order for me to continue with the problem, I got to figure out what that is. I need to go to my calculator. And I need to say, in a fraction, -3 plus the square root of 5 over 2. X equals -0.3897. Oh, sorry. 38197. I missed a number. That's when it's -3 plus root 5 over 2. What else do I need? Minus. X equals -2.61803. How many decimal places did I go to? Tenths, hundredths, thousandths, 10,000, 100,000ths? Probably 3 is okay. Tenths, hundredths, thousandths to the thousandths is okay. So if I did that, this one would really be -0.382. And this would be -2.618. But I do want you to be at least that exact. Fair? So that means I have 2 solutions, and one of them looks like this. And the other one looks like this. -0.382 comma something. -2.618 comma something. Guys, how do I find that something?
Plug it in. Putting one of the y equals.
Yeah, I would go back to the y equals, right? Which one would you use?
First
The first one? Me too. So I add 4 to my x value to get my y value, right? So -0.382 plus 4. 3.618. -2.618 plus 4. 1.382. Those are my points of intersection. This is my actual solution to my system. This is the solution to my x values, right? But we know better than to think that's the answer to our problem. We have to find the points of intersection. That gives me the x value of the points of intersection. I have to go back and find the y value, don't I? Okay. Let me show you something real quick. Sorry, I just added a page and I put in y equals x plus 4. And then I'm going to go to the line 2 and put in x plus 2 squared plus 1. Now, did I expect them to cross on this side? Aren't both of my x's negative? Okay. So I could do menu, analyze, intersect. Put it on the left-hand side of that dot, that intersection, and then move it to the right-hand side of that. Look what it says. Negative 2 point, oh, my calculator's low. Negative 2.62, 1.38. Yes. Menu, analyze, intersection. Put it on the left-hand side and move it to the right-hand side. And this says negative 0.382, 3.62. Perfect. So that's how you would do it if you were graphing, right? This is substitution. Any questions? No, there's not a lot of questions because we've already done substitution, right? The questions I'm concerned about you having are not about the substitution, but just about the arithmetic and the math. You okay with that? Okay. So if I gave you an example on substitution, what else do I need to give you an example of? Elimination. Okay? X squared minus 7x plus 11 equals y minus 1. And negative x plus y equals negative 4. Now, this is going to be a little different than you're used to, because what we did before was we lined up all the x's, we lined up all the y's, we lined up all the equal signs, and we lined up all the constants, didn't we? What? I don't know what it's doing. I'm sorry. It's freaking out. Is it good now? Maybe it doesn't like orange. Okay, I'll use a different color. How about purple? Is that okay? Okay. Why is it? Okay. If we're eliminating something, what are we trying to get rid of? Either the x or y. Okay? So this has to be a really concerted, concentrated effort on what variable we're trying to eliminate here. Okay? Could I eliminate these x's very easily? Yes, I would multiply this bottom equation by 7, right? But if I did that, what would I have left? I would have an x squared and a y. Did that do me any good? No. In the second equation, is there an x squared to eliminate? Even if I did, what would I have left over? X and y, x and y. Didn't do me any good. I need to find the variable that when I eliminate it, that whole family of variables is gone now. Okay? Before I was just trying to eliminate one variable. Now I'm trying to eliminate a whole family. We want to get rid of the y's, don't we? Okay? In order to get rid of the y's, we really want to have some sort of structure set up. Okay? So what I'm going to do is subtract a y from the numerator, from both sides of the first equation. X squared minus 7x minus y. I also want my constants all on one side, don't I? So let's add 11 to both sides. Are you okay with that?
Is it adding or subtracting?
Thank you very much. It is subtracting. I was looking at that sign instead of the other one. So that gives me equals negative 12. Everybody okay with that? Now, when I rewrite this bottom one, I'm going to line up the terms that I can line up. Okay? So I'm going to put the negative x here, the positive y here, and the negative 4 here. Well, wasn't that nice? Why is it nice? Yeah, the y's are going to eliminate perfectly, aren't they? They line up perfectly, and if I add them together, if I combine them, those are going to eliminate right away. So good for us. So combine these two equations. X squared. Now what? Minus 8x. That's 0. And that is negative 16, right? Well, now it's a quadratic. Now where do I want my constant? On the other side, right? So we can add 16. Sometimes it's trial and error figuring out where your constant is. Based on what you're trying to get rid of, you may want your constant on the other side, you may want it on this side. So we could have, in this case, added the 1 to both sides, and then we would eventually had to have moved the 4 as well. Okay? So this gives me x squared minus 8x plus 16 equals 0. How do I want to try to solve that? Factor? What multiplies to be 16 and adds to be negative 8? Ooh, that's nice. X minus 4 and x minus 4. So what's x equal? 4. Both times, right? Okay. So how many points of intersection do I have here? Just one, right? I only have one x value. How do I figure out what my actual solution is? God bless you. Put it up here or here, right? Do you want to substitute it in the top or substitute it in the bottom? Bottom, okay. So negative 4 plus y equals negative 4. Y equals? 0. That's my point of intersection, isn't it? How could I check that in my calculator? How could I graph these two equations? Can I graph those two equations? I could, but I have to solve each one of them for y before I could do that, right? So it's an easier way to check and see if this is the right answer. Plug it in, okay? So if I substitute in the top equation, I get 4 squared minus 7 times 4 plus 11 equals 0 minus 1. Everybody see where I got all that? What's 4 squared? 16 minus 28 plus 11 equals negative 1. 16 minus 28 is? Negative 12 plus 11. That works. So we know it's the answer? Oh, it has to work for both, doesn't it? Okay. So negative 4 plus 0 equals negative 4. Oh yeah, I don't even have to go to the next step, do I? We know that works, okay? So is this the solution? Good. Any questions? So we talked about graphing in general. I actually showed you graphing when I showed you the substitution, right? When we checked it. Here's the substitution example. Here's the elimination example. Okay? In your homework tonight, you have graphing, solving by graphing. You have solving by substitution. You have solving by elimination. Any questions? Okay?